I'll start by introducing myself. So I'm David Kane. I'm a data scientist and researcher, and I do some freelance work, and I also work quite a bit with an organization called 360 Giving, and we help grant makers, particularly in the UK, share data about who they fund. And so we have a data standard to help them do that, and then we have a series of tools to both help them share the data and help them use the data. So one of the things that we've been using a lot recently is Colab Notebooks, both as a way of kind of accessing the data that publishers, grant makers share, but also then kind of analysing it and creating visualizations and things. So I will share my screen, and hopefully it'd be good to get some thumbs up if this works. Let's have a look. Yeah. Okay, so hopefully you can see the screen share. I've tried, as I say, to zoom in a bit so that it's fairly clear on the screen, but do kind of move your screens around to make it as big as possible. And as I say, you can, if you've got enough screen space, you can try and look along. So this is Google Colab. So this is a kind of interactive programming environment that's been created by Google, and that means you do need a Google account to use it. So it's all linked to G Drive, Google Drive. So you can use it if you've got a work account with Google. You can use that, or a personal one. And essentially, Google have provided for free some server power behind this, so that you can kind of run the code on their servers, and they can even, if you're doing particularly exciting machine learning things that needs a bit of oomph behind it, you can request a GPU, for example, to kind of beef up what the resources that are available. But it is a kind of a free programming environment. The downside of that is that the environment they give you is not persistent, so it doesn't kind of stick around. So if you work on a notebook for a little bit, the notebook itself will be saved, so you don't lose any of the code that you've written or the notes, but you will lose the kind of results and the files you've created, and you have to kind of create them again. So that's one of the ways that notebooks work, is that they are designed so that you can kind of run them from scratch every time. So this is Google's environment. It is heavily based on a technology called Jupyter and Jupyter Notebooks, which is a kind of Python programming environment that's designed to run kind of on your own machine or on a server. So even though you're using Google's environment, it's very possible to download these the files that they create, the notebook files, and then run them on your own computer in the same way, with a little bit of kind of setup before then. It's mostly based on Python, but it is possible to use other languages, particularly in the Jupyter Notebook kind of local version. And as I said, a notebook is just a file, but Google does give you that environment for using it. And I guess one of the main things to say is that it's very hard to break things. So the worst case scenario is you duplicate the notebook and start again. Google have put lots of protection in their own servers, so it's very hard to do things that go so wrong that they're kind of irretrievably broken, he says confidently. So let's get started. What I'm going to do is, as I say, I'm going to use the notebook to kind of go through some of the different functions that are available and some of the different things that you can do. If I've got time, I'll demo some of the more advanced functionality, like being able to create interactive maps and charts. There'll be a bit of kind of introductory sort of Python coding as well to show you what's possible. So I guess the first thing to start with is, why would you use a notebook? So They're heavily used in kind of data science and research these days, and they're a really fantastic environment for doing data analysis. And one of the advantages that a notebook gives you is you can show your working. So you can both show the code that you're using to do certain things. You can see the outputs of that code, but you've also got the facility to add kind of the notes and text that describes what you're doing. So it's really kind of everything in one package. And typically they would be used for something where you're taking some sort of input, so a data set, for example, doing some manipulation to that data and then getting some sort of output. So whether that's a visualization, a table, a CSV that you download of the data. So really kind of quite flexible for a lot of uses. As the Colab part of the title suggests, they're very useful for collaborating with others. You've got all the usual kind of functionality of Google Drive in terms of sharing and that sort of thing. They're really useful for kind of prototyping and testing ideas. The overhead for getting them up and running is literally just a button press, as I'll show you in a minute. And that means it's really kind of easy to get up and running and prototype and test ideas. One of the things we do at 360 Giving is we've got a kind of minimum viable notebook, we call it, which is like got the basic framework you need to be able to access the 360 Giving data store, and then you can very quickly kind of build on top of that to test an idea or do some analysis. And the notebook format that I'll show you has sort of code cells, and that means you can really kind of see what you're doing as you go along. You can make changes, and you don't have to run the whole thing again in order to kind of change one thing. Yeah, that makes them, again, really suitable for kind of prototyping and testing ideas. And as I said, in 360 Giving, we use Colab Notebooks a lot. And they're actually the main way that we give developers or researchers access to the 360 Giving dataset through the data store. So hopefully that all makes sense. Let's get into notebooks. So this is what you're presented with if you go to colab.research.google.com. I've put a link to that in the chat. And to get started, you can just simply click New Notebook. It's also possible to upload them if you've got a Jupyter notebook yourself. So this is what we're presented with when we first start. So you get a blank sheet of paper, as it were, and the first thing we've got here is a code cell. You've also got this button that says connect. So one important thing to remember with notebooks is you've got sort of two halves of it. So you've got the notebook itself, where the code and the text that you're creating sit, and that very much is just a file. It's got, you can see the file extension up here, IPyNB. But behind that there is a server, and that's what's running the actual code. So we do need to, it will connect the first time you run a cell, or you can connect to the server. And as I say, and it tells you a bit about what it's provisioned in terms of the RAM that's available and the disk space you've got. And as I say, that it's important to remember that that's not persistent. So anything you save to the disk, for example, won't be there next time you run the notebook. You need to make sure you save that to your own computer or save to Google Drive, and I'll talk a bit about how to do that. So what is a notebook? So a notebook's made up of cells. So we've got a blank cell here, and you see if I hover underneath it, I get an option to add either a code cell or a text cell. And these cells are run on demand. So they're only run when you either click the play button, or there's a keyboard shortcut, which is Shift plus Enter. So if we start with text cells, these are used to kind of add structure and context to a notebook. And I don't know if anyone's had experience of Markdown before, but there's a particular sort of text formatting that you can use to add structure to those. And so you can do things like, if you start the line with a hash sign, it will do it as a heading. And then you can add simple text. And there's a few features in Markdown that might be useful. So you can add things bold, or you can add lists of things using a kind of fairly simple syntax. And you can, if you do square brackets, you can link to things as well. So there's our link to giving. And these, you could see how these will let you kind of add quite detailed and rich information about what you're doing. So what you might describe here is what the purpose of the notebook is, what you're aiming to achieve, what the inputs are, what some of the dependencies are. I'm trying to give people the context that if they were running it themselves, they'd have the information that they needed to kind of know what they're doing. So that's a text cell, and you can add as many text cells as you like, and you can kind of intersperse them all through the document. The next bit is code cells. So you can see we've got a code cell here. And I'll do some demonstrations of these, but so they mainly contain Python code. It's possible to run kind of bash commands on the server as well, which can be useful for installing extra things that aren't included by default. And you can use things like print to print things out, but also the last variable that's included in your cell is shown as output. So I'll give a demonstration of that in a minute. And the other thing that's important to know is that if you define a variable in a code cell, it's available after that in any of the other code cells. So you can really start to kind of build up a script, but make sure it's interspersed with kind of text and things so that people can follow along with what's going. So let's start by doing some very simple code and adding some numbers together. So we'll say our variable a is equal to 1 plus 1. And then if I put a at the end of the cell, you can see it gives us the answer. And that variable is now stored in a. So if we use it in another cell, it's still there. In fact, we can even do things with it. So we can say a times 2 is 4. So that's our kind of very basic maths with the code. We can also use strings or text. So if we say that b equals hello and c equals world, and we could add those strings together to join them, and then show what the result of that is. I'm using Shift-Enter to run the cell, and that tells us, that gives us an output of hello world. So that's a very simple way to start using data in Python. We can also do things like string formatting, which is where you put a variable inside a string so you can print it out using the curly brackets here. So we're taking our variable a that we used earlier and putting it in this formatted string. There we are. The number we found was 2. You might also, if you've used Python, you'll know about things like lists. So here's a list of some of the things that you might encounter at this event. And we can use that list by iterating through it. So we're going to say hello to each of the things that are at the festival. So we've taken our list of items, we're going through each one and then printing something for each of those items. And it's worth, yeah, there's lots of kind of basic stuff with Python that you can, it's a really good environment for kind of getting up to speed with. And as I say, the really nice thing about it is if you make a mistake, so I've got a typo here, it will tell you what the mistake is. You can go back and correct it and then run it again. And you don't have to run everything right from the start in order to get to that point again. So that makes it really kind of nice for iteratively developing and not having to get it all right first time. So the next thing it might be useful to look at is working with data, since we're at a data conference. So I use a library called pandas, which is quite popular. I see a couple of people have mentioned that in the chat. And pandas is a set of utilities for working with data in Python, and there's a set of kind of extra modules that are included in every Google Colab instance, and pandas is one of those. So in order to get it up and running, you do have to import it, so it's not kind of there by default, and sort of by convention you tend to call that PD. So that now means that's run successfully, so that's pandas is kind of up and running. And one of the nice things about pandas is it makes it really easy to fetch some data from the internet. So I'm going to fetch some 360 giving data now. I'm using DF to stand for data frame, because that's what pandas calls the tables it stores data in, and I'm using this file, which is a 360 giving file from the Indigo Trust. I'll just put DF at the end here so we can see what's in the data. So it's going to go and fetch that data. One thing about fetching data, you're using Google servers to fetch the data there. So the data is never on your own computer. So that means that you've got kind of Google speed for fetching it as well. So you're not reliant on your own kind of broadband speed for fetching it. And you can see this is a 360 giving format file. So each line is a grant, and it tells you who the funding is from, in this case Indigo Trust, and then it tells you who this is to. So this is an organisation called Thames Reach, and it tells you some information about it. So we know it's in pounds. This one was for £5,000. It was in 2005, and there's various other details, including like the postcode of the organisation that was received it, and some other stuff about how long it was for, that kind of thing. So once you've got this data, so this data is now loaded in my notebook, I can then start to look at it. So there's a great function called nUnique, which will tell you for each column in your data, which pandas calls series, you can tell how many unique values there are in there. So we've got 492 rows in total. There's 492 different identifiers, which is good. There is one funder, which we know is right because this was from the Indigo Trust, and there's 282 different recipients. So some recipients will have received more than one grant, one currency, so that means it's all in pounds, lots of different amounts. So you can get a feel for some of the data, and there's other functions you can use to kind of explore the data. So one of the kind of variables that caught my eye is this plan date duration month. So that tells you how long the grant is for. So whether it's for 12 months or 24 months, and there's 8 different values for this. So that is a good variable to use to test out some of the functions we can do. So let's have a look at that column. So you can, if I'm going to copy the name of this column because it's quite long, and then you can use square brackets to just have a look at that column. So you can see we've got, we don't have any other information about these rows, but we can see the first one's 12 months, there's a 36 months, and there's a couple of 6 months in the very last one. So it just gives you a sense of what the data is. There's also a really useful function called value counts, which will tell you for each different value. So here's our 8 different values that we've got, how many are in each. So the most grants are for 12 months. There are some for 36, some for 0, which might be something like capital funding, which doesn't, the sort of length doesn't apply, and a variety of other ones. It's ordered at the moment by, with the most value first. It might be better to sort by the index, which is the number of months, and then we can kind of get a better sense of, it's taken a while. There we are. After different months, so 27 for 2 years, 43 for 3 years, etc. We can also add to frame to the end, and that makes it look a bit nicer, basically. Let me, someone's asked for the link to the CSV. I'll paste the CSV itself in the chat. If you're interested in 360 data, you can also go to data.360giving.org. And that's got a whole list of all the files that are available, that have been published. And one of the great things that's inbuilt to pandas, if we've got our value counts sorted, is it's really easy to plot. So bar h means bar horizontal. So if you put dot plot dot bar h, you can very easily get a bar chart, and that I think can demonstrate how it's really easy to kind of prototype, to do kind of analysis on the fly. And so whereas previously I would have kind of done this in Excel and done a pivot table, and then sort of left the pivot table on a sheet and forgotten that I'd done it at all. Here you can kind of build up your analysis as you're going on along, and then kind of tidy things up to turn them into a useful notebook. So in terms of that sort of prototyping and testing ideas, it's really good for that. So the other variable that caught my eye was the country of recipient. So if I did the same for that, so recipient org country, so you can see these are all the countries that Indigo Trust work with. Most of them are in the UK, but then they have a lot of programs across Africa. So these are the number of grants in all of those. But what we might want to do is, as well as looking at the number of grants, we might want to look at the amount that's awarded there. So pandas has these set of functions around grouping. So here we're going to say I want to group the data by the country, and then show the amount awarded, and then I'm going to do a sum. So that will tell me for each country how much has been awarded. So you can see here that the grants to the UK are about 11 million. There's 2 million to South Africa, and various other amounts. And don't forget, this is where the recipient organization is based. So the actual activity itself may take place in a different country. So I know they do fund UK NGOs who then go and do work in other countries, for example. We may also want to look at not just the sum, but the mean, and there's lots of different calculations available. So here you can see some of where the bigger grants have gone. So the Netherlands and Sierra Leone, for example, have got a bigger average size grant than the UK. And if you wanted to, again, turn this into a bar chart, it's really straightforward to do that. So I've just added plot.barh to the end, and that's turned it into a bar chart. There's some more sophisticated stuff. There's a great function called describe, which does a lot of these calculations all at once. So it looks like a bit of a mess, but here we've got the count, so the number of grants, the mean size, the standard deviation, minimum, and then quartiles and median. So that's a great function for kind of getting a handle on your data straight away. And finally, you can do crosstabs, so you can compare two different variables. So I'm going to compare recipient organization country with our plan dates duration months. And so here you can see we've got the plan dates across the top as our columns, and then our rows are the countries. And you can see for the UK, it's probably got the widest range of values outside of 12 months. And most of the other countries, they're kind of concentrated in around 12 months. Okay, so that's the kind of basic data analysis we can do with pandas. It's pretty straightforward to get to something, and then there's a lot of flexibility and sometimes less straightforward to do some fairly kind of sophisticated analysis. One of the other things I want to show you with pandas, which I think is a kind of common use case, is then filtering data. So we can use equals to filter data. So here we have, if we wanted to say recipient org country equals UK, and if we do that, you see we got a list of true and false as to whether the each row, the recipient org country, was the UK. And then we can use that sort of in square brackets itself within the data frame. So this was my filter in the middle, and then I've surrounded it by square brackets and the data frame, and that uses that then to filter the data. So here we've got 244 rows, and these are just the rows where the recipient org country is the UK. We can also take our filter and we can turn that into a variable. And then that variable is available and can be used to filter the data frame itself. So if we wanted to then do something we've done before in terms of, I have to remember. Sorry, I'm slightly losing where I am. This is our plan dates duration months, but only showing values for the organisations that are based in the UK. So you can see we've got fewer months than we would have if we were just looking at the whole data set. And we can even do a value count on our filter, so it will tell us how many true and false values we have. So we've got 244 organisations in the UK and 248 outside. We can also use the tilde operator. So that's a little squiggly line. It's above the shift on my keyboard, and that basically gives you the opposite. So it will find all the ones where in UK is false. So these are all the grants to organisations outside of the UK. So we could compare our list of grants in the UK to grants out of the UK. So here we've got 224 grants are for 12 months outside of the UK. It's only 157 inside. So we're kind of using it to start to generate insights. And very quickly, this is where it starts to get a bit more complicated, but we can also edit data. So what I noticed was some UK grants have got UK and some say United Kingdom. So let's call this use United Kingdom. So here we're picking up any grants where they've used United Kingdom rather than UK. And so we've got a series here. There's then a function called loc, which means we can edit the data. So we can use our filter here. And if I use a colon, so we've got the rows we want to select and then the columns we want to select. And a colon will use all, will select all rows. So here's the three rows where we've got United Kingdom rather than UK. We can also select just one column. So here we're saying for all those that say United Kingdom, give us the recipient org country column. And we can then use this like any other variable and change it. So I'm going to say equals with just one equals rather than two. So 2 is for comparison and 1 is for assigning it. We're going to change these so they now say UK. And then finally, we can see that these have all changed by repeating that same query. So they now all say UK. So if we then wanted to rerun this query and have a look, you'll see that these numbers will change. So that's gone from 157 to 160. Okay, so again, there's quite a lot of flexibility in terms of editing data. You can use quite kind of build up sort of sophisticated criteria and then change the data based on that. The one other thing that I thought it might be useful to show you is now you've got this data. As I say, one of the things that that happens with a Google Colab notebook is that once you're there, all this data is gone and you have to kind of start from scratch. So what if you want to kind of save it? So there's a little file icon here, and this tells you the files that you've got. I think every notebook starts with this kind of sample data that you can use if you want to. And you can use that like a normal file. So pandas has a to-CSV function, so I can make any changes. And it's worth saying any changes you've made aren't reflected in the original file. Originally for this one we downloaded it off the internet, so we've got no way of kind of altering that file. It's only changed in the data that's kind of held in memory in the notebook. So if we want to save it, let's use this to-CSV function, run that, and then eventually if I refresh it, we've got our data there. Now, as I say, next time you come to the notebook, that won't be there, but you can then download that to your own computer and save it, and so that's saved up there. And the other thing you can do is connect it to your Google Drive. So this button here says Mount Drive, and that will, that allowed you to connect to your normal Google Drive, and then you can import and export and save files as if that was on, it was kind of on your own computer. That's yeah. So that's how to use files, and it's possible to upload files there as well. So if you've got data that you don't want to put on the internet, you can upload the file there and then kind of load it from there. So yeah, that's my very quick introduction to using Colab Notebooks. I haven't got time to show you some mapping stuff and some interactive things that are really kind of easy to do. But what I'll do is I've got a Colab notebook which has all of the sort of Blue Peter style one I prepared earlier. So I'll share that in the chat. And yeah, so that kind of shows all the things I've demonstrated today. There's some stuff at the bottom about adding maps and other interactive charts and things. And there's a list of kind of resources and useful notebooks on there as well. So do have a look at that. Feel free to, you've not got edit rights to it, but you can duplicate it and kind of play around with it. And I would definitely kind of encourage you to explore and remember that it's very difficult to break anything. So it really is an environment where you can kind of test and get things wrong and improve things. Just having a quick look at the questions. In terms of resources for getting started, so in terms of Python, there are some great resources. There are loads and loads of courses around. I'm sure others may have recommendations. I used a thing called Learn Python the Hard Way, but that was quite a long time ago, so there may well be better options. And one thing I would say is that Colab Notebooks are a great resource for learning because you can get so much. You can make mistakes, and you're not having to kind of run programs and wait for them to finish and then work out whether something's gone wrong. You get that kind of instant feedback. So in terms of Ben's question about using, should you learn Python and then use Colab or vice versa, I think they're a great place to get started. And it's a really kind of safe environment to make mistakes and learn that way. Some of the other questions. So in terms of whether to use Jupyter Notebooks or Colab Notebooks, I think it's, yeah, some of it's about preference, some of it's about collaboration is much easier with Colab Notebooks. So if you are in a kind of team and you're doing research and things, then they're really useful for that. There may be other things about, so certainly things like using data that might be private or you might not want to share, then you may be better off using a Jupyter Notebook, and then you're in control of where the data is. Good questions. In terms of observable notebooks, so observable notebooks are a very similar concept, but they use they use JavaScript, and they're very heavily weighted towards data visualization. So they're, I think, created by the guy who made D3, which is a sort of JavaScript visualization library. It's not particularly my area of expertise, that visualization stuff, but I think observable notebooks are really powerful for that data visualization. So it could be that Python is the Colab Notebooks or Jupyter Notebooks are the right place to do the kind of analysis and cleaning of your data, and then observable notebooks are the right place to then take it to visualize it and do some exciting things with it. Interactive form options, yes, there are definitely options to do that kind of thing. I've never quite got it so that you can almost run them as a sort of app that people can sort of self-serve with the data in that way, but I think that is possible. And certainly in the 360 Giving, the way that we use Colab Notebooks, we've set up little form fields to help kind of people guide people through. In terms of version controlling notebooks, that's really difficult, and is one of the drawbacks. So yeah, there are options, particularly with Jupyter Notebooks, for using Git and other kind of version controls tools with them, but they're not ideal. The file format particularly doesn't sort of lend itself to version control very well. So that's one of the kind of downsides and drawbacks. Great, and there's some recommendations for Python courses in the chat. Yeah, great. Okay, well, I hope that was useful. Happy to kind of connect with anyone who would like to learn more or learn more about 360 Giving. There's a couple of other sessions with 360 Giving. Catherine is doing an introduction to GrantNav this afternoon, and then we've got a networking session for funders tomorrow as well. But there's lots of us around on both of the remaining days. So yeah, do get in touch, and yeah, thanks everyone.